on one side we add water, on the other side concentrated chlorine. They are added from the top, and during their passage down the tower they get thoroughly mixed, and water is also passed through. So, treated water, it is taken out from the bottom, and for filtered water about 0.3 to 0.5 ppm of chlorine is sufficient. We cannot add chlorine amount of chlorine higher than this. So, this is chlorinator, it is a long tower. From this side raw water is passed, from this side concentrated chlorine solution is passed. These are baffle trays, and the two gets mixed, water and chlorine, and water becomes water is sterilized water, it is coming out through this outlet. So, this method addition of chlorine has certain advantages, and these are that this method it is chlorine, it is effective and economical. It requires very little space for storage. Chlorine is stable and it does not deteriorate on keeping, and it can be used at both type of temperature. It can be used at low and high temperature. It introduces no salt impurities in treated water, or hence we can say it is most ideal disinfectant. But chlorine has certain disadvantages also, that by in this method we cannot use excess of chlorine. If excess of chlorine is added, it produces an unpleasant taste and odor to the water. Water becomes unpleasant in taste. Sometimes excess of chlorine it may produce an irritation on mucus membrane. Quantity of free chlorine in treated water, it should not exceed 0.1 to 0.2 ppm. So, this is chlorine is quite effective at low pH 6.5 pH, below 6.5 pH, and it becomes less effective at higher pH. So, if the taste of water becomes unpleasant by the addition of chlorine, so to regain the taste of water ammonia is passed. So, this was the sterilization of water by adding chlorine. Then the second method is by adding chloramine. So, chloramine, so for adding chloramine, the mixture of chlorine and ammonia, or we can say chlorine and ammonia are passed simultaneously at the same time in the ratio of 2:1, 2 amount of chlorine, 2 volumes of chlorine, 1 volume of ammonia, and during their mixing compounds like monochloramine and dichloramine are formed, and these are also strong disinfectants. So, chlorine, ammonia, the two are mixed in the ratio of 2:1, ClNH2 monochloramine. So, we have only one chlorine atom. So, this is called as monochloramine, and if excess of chlorine is used, then we can get dichloramine Cl2NH. So, these ClNH2 they react with water and they form hypochlorous acid, it is a disinfectant. So, advantages of this method, chloramine is much more lasting than chlorine alone, and hence it is a better bactericidal than chlorine itself. It does not produce any irritating odor, it imparts good taste to water. Then the third method is by adding bleaching powder. Bleaching powder is a CaOCl2, calcium hypochlorite. So, in small water works, about 1 kilogram of bleaching powder to the 1000 kiloliters of water, it is mixed and water is kept undisturbed for several hours. So, chemical reaction takes place between water and bleaching powder, and it produces hypochlorous acid, which is a powerful germicide. So, bleaching powder CaOCl2, it is added into water. The products are calcium hydroxide and chlorine. Chlorine, it reacts with water to form hypochlorous acid, and this hypochlorous acid it attacks on germs because it is a germicidal, so germs are killed. So, drawbacks of this method, that bleaching powder introduces calcium in water, which makes water hard. You have studied that the presence of calcium in water makes it hard. So, bleaching powder is a salt of calcium. So, when bleaching powder is added, water becomes hard. During storage, if bleaching powder is stored for a long time, so it deteriorates, decomposes due to its continuous decomposition. So, before using bleaching powder as disinfectant, it should be analyzed for its effective chlorine content. So, it should be tested because so that we can check that it has it deteriorated or not. And only calculated quantity of bleaching powder should be added, because if excess of bleaching powder is added to water, it gives bad taste and smell to treated water. So, this was about chlorination by adding chlorine, by adding chloramine, or by adding bleaching powder. The third type of sterilization is by ozone, and the step is called as ozonization. Ozone is having chemical formula O3. Ozone gas is an excellent disinfectant which can be produced by passing silent electric discharge through cold and dry oxygen. So, you can see this equation, 3 O2, 3 molecules of oxygen, silent electric discharge is passed and oxygen gets converted into ozone. Ozone is highly unstable and it breaks down and liberates nascent oxygen. Ozone, it gets decomposed into oxygen and nascent oxygen. Nascent oxygen means it is atomic oxygen. It is very reactive and it is a germicidal. The nascent oxygen is very powerful oxidizing agent and it may kill all the bacteria, as well as it oxidizes the organic matter present in water. So, this is ozonization. So, plant used for ozonization is made up of iron. It is having perforated curved roof. This roof is curved and it is having a bed of charcoal, sand, gravel, sand and charcoal, and ozone gas is passed from below. So, through this inlet ozone gas is passed. Water comes in contact with nascent oxygen formed by decomposition of ozone, which sterilize water. Sterilized water falls and get collected at the bottom of plant, from where it can be taken out through tap. So, you can see that here from this side we are entering ozone gas, impure water is passed here and ozone gas gets decomposed into O2 and nascent oxygen. Nascent oxygen makes water free from microorganisms and pure sterilized water is collected at the bottom, from where it can be taken out through this tap. So, this method also has certain disadvantages. This is a quite expensive method and cannot be employed for municipal supply. Advantages: disinfection by ozone is costlier than chlorine, but it removes color and odor without giving any residue. So, it is a better method than chlorine. Its excess is not harmful because it is not stable, it is unstable and it decomposes into oxygen and there is no more ozone in water. So, water is free from any chemical present in water. So, the next method of sterilization is by adding KMnO4, which is called as potassium permanganate. It is a strong oxidizing agent and it also liberates nascent oxygen on decomposition, which can kill germs and bacteria. So, you can see equation here, 2 KMnO4, it gets changed into K2O, 2MnO and 5 atoms of oxygen, nascent oxygen they are produced. So, this nascent oxygen kills bacteria and germs. So, this method of sterilization is used for the water of wells in villages. by ultraviolet rays, which are we can say UV rays, which are very effective in killing all types of germs and bacteria. So, how we apply this method? These rays are produced by mercury vapor enclosed in quartz container. Sterilization by UV rays is mostly done for disinfection of swimming pool waters. The last method is by aeration. The process of spraying water in fine streams or droplets into atmosphere is called as aeration. So, you can see water under pressure is passed through this pipe and it sprinkles in the form of stream, and it comes in contact of air and oxygen, and which kills germs and bacteria, and purified sterilized water is collected in this container, and from where it can be taken out. So, we can have a look on this method. Water is forced under pressure through a perforated pipe. Perforated pipe means a pipe which is having holes. Water comes in the form of sprays into atmosphere, and it comes in contact of oxygen and UV rays of the sun, which kills bacteria and germs and oxidizes organic matter present in water. Aeration of water, it also removes unpleasant odor of water, and purified water is collected in a tank placed below. So, this was all about the purification of water. So, we can see flow diagram of drinking water treatment plant. So, from here raw water is passed and through alum is passed. This is the mixing tank, and here coagulated water, it is passed filtered through this filtration gravity sand filter, and filtered water is taken out, from where on this side we can add liquid chlorine. So, water gets sterilized and water free from any type of suspended or microorganisms can be taken out. It is used for town supply. So, this was about the purification of water by different methods. So, now we come to desalination of sea water. Through this method, desalination of water, sea water means we can make sea water for used for drinking purposes. So, water containing dissolved salts like with a peculiar salty or brackish taste is called as brackish water, and sea water is brackish water because it contains salts of about 3.5%, and this water is totally unfit for drinking purposes, and it is made fit for drinking by desalination. So, what is desalination? The process of removing extra common salt from water is known as desalination. So, it can be done by two methods, reverse osmosis method and electrodialysis method. We will study here reverse osmosis method. So, reverse osmosis method, to understand this method, first of all we must know what is osmosis. The method is based on important property of solution, which is osmosis. And what is osmosis? Two solutions of different concentrations, they are separated by semi-permeable membrane, a membrane which allows only the entry of water particles, and all other particles are retained by this membrane. So, two solutions of different concentration, they are separated by semi-permeable membrane. Flow of solvent takes place from dilute to concentrated side. Due to osmosis, a pressure is set up on the surface of solution, and this pressure is known as osmotic pressure. But if external pressure higher than osmotic pressure is applied on the concentrated side, the flow of solvent is reversed. It starts flowing from concentrated side to solution, dilute solution side, and this is known as reverse osmosis. So, desalination of sea water is based on reverse osmosis, and this method can convert sea water into pure water. So, method of this reverse osmosis is performed in a tank. It is having a semi-permeable membrane of cellulose acetate. This membrane is permeable to water, but non-permeable to impurities and ions present in sea water. This membrane can withstand high pressure which is needed for reverse osmosis. On one side of membrane there is sea water, on the other side pure water is collected after reverse osmosis. So, you can see here that this is the semi permeable membrane, and on this side we can collect pure water, on the side there is the sea water which is passed. When it is passed, we pressure is applied here, so more than the osmotic pressure, and due to this pressure the solvent particle they pass through this semi permeable membrane, and water free from impurities is collected here and pure water is collected here. So, a pressure of the order of 60 to 70 bar is applied on sea water side, reverse osmosis occurs, pure water forces its way out of semi permeable membrane, leaving dissolved salts on the other side. Pure water which is so good for drinking purposes can be obtained. So, many countries have employed desalination plants to meet the requirement of drinking water. So, advantages of this method: it can remove ionic, non-ionic, colloidal or high molecular organic weight matter. It can remove colloidal silica. Lifetime of the membrane is of 2 years. Membrane can be replaced within 2 minutes and water supply remains uninterrupted. Due to low capital cost, simplicity, low operating cost, this method is used for converting sea water into drinking water. So, this is all about drinking water and its purification. Thank you.